Hey guys, welcome to Notes 8-3 for proportional parts and indirect measurement. It's a couple more things we do with proportions, and here we go. Example number one, it says find the missing length, and we see we have some lines drawn here. A thing we know about parallel lines are that the lines that intersect them, these transversals are proportional since these lines are parallel going across. So I can set up a proportion with this to solve for my side x right here. One way to set up my proportion is I could say 4 over 7 equals 8 over x. I could also set this up as 4 over 8 equals 7 over x. Either way really doesn't matter as long as you go from the same corresponding pieces to the next. All right. I like to set it up as 4 over 7 equals 8 over x. And then I can cross multiply. 4x equals 56. Divide by 4. So therefore x equals 14. Okay, and that kind of makes sense here. If we look back at this, if we go from 4 to 8 and we're multiplying by 2, then we go from 7 to 14, also multiplying by 2. Again, parallel lines make proportional parts there. My next example here says find the length of VW. I see that VW is right here on this triangle here, the outside triangle. And take a minute here, just kind of look at this diagram, see what we're given. VW is represented by 2x plus 4, all right? And I've got 21 from W to G, I've got 18 from W to H, and then 24 from W all the way to U. All right, this diagram in here involves two triangles if you see it. There's a triangle set inside of a bigger triangle, and anytime you have two triangles like this, it's always easier for me to see these if I redraw them. So I'm going to take some time to redraw these two triangles here. I'm going to draw the smaller triangle and the bigger triangle. Alright, so 21 here, and then 18 here, and then 2x plus 4 on the big triangle, and 24 on the big triangle as well. I could label the letters of the vertices, but I'm not going to take the time to do that. It's not completely necessary for this case. Now, since these triangles are redrawn, it's a lot easier for me to see the proportional parts. And again, since these lines are parallel, and also since these triangles are set inside of each other, they're going to be congruent. First off, this angle right here is W in both triangles, so it's congruent to itself. Then, since these lines are parallel, I've got corresponding angles here for G and V, and then I've got corresponding angles for H and U. So, since that's the case, both these triangles are similar. All three angles are the exact same. Since they're similar, I can redraw them then, and then I can set up a proportion to solve for x, and then come back and find the length of VW. So set up our proportion. I'm going to say 21 over 2x plus 4 is going to be equal to 18 over 24. Hopefully by now you guys are comfortable setting up proportions, and you know how to do that. All right, cross multiply. So I've got 18. I'm going to rewrite here. Hopefully I have enough room. 18 times 2x plus 4 is going to be equal to 21 times 24, which is 504. My quick calculator there. 18 times 2x, make sure you distribute here. 18 times 2x is 36x. 18 times 4 is going to give me 72. Still equals 504. Subtract that 72 over. So I've got 36x is going to be equal to 504 minus 72 is 432. Then divide by 36. So x is going to be equal to 12. All right, I'm not done yet. We found x is 12. Now I'm going to come back up here and plug it in. 2 times 12 plus 4. So 2 times 12 is 24 plus 4 is 28. All right, and I see that if WV or VW is 28, that's my answer. And so then that matches up. 21 over 18, and then 28 over 24. Those sides are all proportional to each other. All right, last example I want to go over is called an indirect measurement. This is when we measure things indirectly if things are too tall to measure directly. We're doing an example like this in class. This one here, it says, in sunlight, a 3-foot tall child casts a 2-foot shadow. The same time a nearby tree casts a 15-foot shadow. How tall is the tree? All right, and to better see this, I'm going to draw a picture. So let's draw the child. All right, and he is 3 foot tall. He casts a shadow. That shadow is 2 feet long. All right, and then we have a tree that's nearby. This is the best looking tree you've ever seen, right? Got a little owl hole in the middle. Okay. Then we also have a shadow that we can measure is 15 feet long. All right, so this is a real world example. If we know the height of a person and the length of the shadow they can make, we can see a tree and we see the length of the shadow. Well, we want to see how tall is this tree. So I'm going to label that X. All right, what I'm able to do then is set up proportional parts. Well, and I know this is proportional because if we had the sun and the sun is casting down the light, I guess, the top of the head, the bottom, tip of the shadow, top of the tree to the tip of that shadow makes similar triangles here. It makes triangles, and these triangles are going to be similar because the angles are all congruent to each other. Okay, this angle is congruent to this angle coming down from the top of the sun, and then also it's going to be a right angle here with the tree and the person, obviously. So all the angles are the same, proportional parts, set up the proportion, let's get going. 3 over x is going to be equal to 2 over 15. Cross multiply 2 times x is equal to 3 times 15, which is 45. Divide by 2. So x is equal to 22.5 feet is the height of the tree. All right, and so obviously we wouldn't be able to measure that directly. I can't go over there and put a ruler up to the tree and measure 22.5 feet, but with these proportional parts that are created, I can set up a proportion and solve for the missing side there. We're doing something very similar in class involving a mirror with proportional parts in similar triangles. Hopefully you guys have gotten that as well. Anytime you have these problems, it's a word problem, draw a picture. It really helps you to see it, and you can set it up from that. All right, guys, hope that makes sense. Proportional parts, similar triangles. Have a great day. I'll see you guys later.